All right. Excuse me. So, as far as this new system for measuring angles, radians, right? The textbook definition for what a radian is any angle theta has a radian measurement of theta equals S over R, where R is the radius of the circle and S is the intercepted arc. Okay, so here's one way to look at this, and there's a really nice animation of this embedded in the lesson right after this. Okay, so take a look at this angle right here, this distance right here, if we call that R. Okay, and then we mimic that distance around the circle here. Okay, so if that's S, so if I had S with the same value as R and I put them in a fraction like so, what do you get when you have the same number on the top and bottom of a fraction? Right? You get a value of 1. So this angle is by my best freehand drawing, that's 1 radian. Okay? And 1 radian, you can see 1 radian is something in the neighborhood of 60 degrees. It's not exactly 60 degrees, but it's in the neighborhood of that. Okay, so this is a different system for measuring angles, right? And I tried to be creative here and draw a whole bunch of these, but this isn't going to work. Okay, so you can see here now, I just took that same piece, I copied and pasted it here. So now you'd be looking at an angle right here that intercepts 2 arc lengths of that distance. Okay, so this would be a 2 radian angle. Okay, can I get one more? Let's see. I don't think I can. No. Let's see. Hold on. Let's see what I can do here. Here we go. Let's do it this way. Not bad. So you can see here's 3 radians. And you'll notice, and this is going to come up in another video, okay, this angle right here is 3 radians, and that's a little bit more than half of the circle. So 3 radians, the 3 radian angle intercepts an arc that has a length that would be 3 times whatever the radius is, so this entire piece. So this is a 3 radian angle stretching from here down to here, just a little bit more than half of the circle. So more to come on that when we start trying to compare degrees to radians and do that conversion, all right? But this formula is going to show up, okay, in a few of the problems that we're looking at. You can always find the radian measurement of an angle if you know the intercepted arc and you know the length of the radius, okay? And these are measurements that you can use, simple measuring tools for, right? If this is the real world and you were having to find the radian measurement or that measurement of an angle like we all do on a regular basis, right? No, I'm just joking. But if I said find the measure of this angle in degrees, there's only one tool that can do that, and that one tool is a protractor, right? How many of you carry a protractor in your back pocket? But if you can find distances, you can find the radian measurement of an angle pretty simply by measuring a radius and measuring an arc length. Okay, so it gives us something that's a little bit more intuitive, and it's not just based on some random arbitrary number of 360 degrees.